So now we're going to take a look at something called the word superiority effect. And it addresses the issue of how we recognize letters versus words. And you might think that a single letter is less information than a whole word, right? And so shouldn't it take longer to identify a whole word rather than a single letter? To study this, the researchers presented individuals with either a word, the example here is the word work, and then they immediately covered up the word with these X's so that they couldn't just keep looking at it. And the word was shown very briefly, very, very briefly. And then they asked a question. Did you see a D or a K? And so, of course, the correct answer would be, oh, there was a K in this, right? Now, they compared how long it took people to figure out if there was a K. And because the letters and words were covered up in this phase, when you're asked this question, you have to rely on your memory. And you have to sort of, take a look at the mental image to answer that. So here, the 4 letters, they're covered up. You're asked if there's a D or K, and you access your memory to see what that might have been. In the letter condition, just shown the 1 letter, covered up with the X's, and then the same question, D or K. And then a non-word condition. So the most interesting finding was that the word was detected faster. So the word condition led to faster responding. And again, that's kind of counterintuitive because there's more items here that you would have to sort of scan through your memory than in this condition. And it was also faster, by the way, than the non-word condition. So there's something that's going on when we perceive a word as opposed to a single letter or a series of individual letters that's different. And the idea is that we perceive words as wholes. So as like a whole unit, not a product of individual letters. And so our knowledge of words actually helps us identify letters. And then that begs the question, well, how is that possible? How do we get to the word without looking at the individual letters? And this is where we get to top-down processing, of course, right? The word superiority effect demonstrates that our expectation of what the word is helps us read it very quickly and helps us then identify what those letters are. So it's also a good example of what's called parallel distributed processing, and seeing this in the recognition of individual letters. So this is what's called an interactive activation model, and we can see that there are arrows right in these 2 directions, huh? So first off, the features. These are the features of the letters, right? The lines and angles, for example, that make up the letter. So you see the features. Based on the features, you put together what the letter would be, and then you put all the letters together and you get to what the word would be, huh? But there's also this top-down processing going on, where once you can anticipate what the word might be based on the context and your memory of what the possibilities are for a word that starts, for example, with the word W and has 4 letters, then the word level also is going to be able to go down here and lead to your perception of these letters. So it's a process that involves both this bottom-up processing from the features to the letter to the word, but also this top-down context and memory-driven process where we figure out what the word should be and from that identify what the letters likely are. And so they identify in their models that these two processes are happening in parallel, in other words, at the same time, the bottom-up and the top-down. And they propose that there are two kinds of connections between levels: excitatory connections and inhibitory connections. So just like your expectation of what a word might be based on the fact that the first letter is a W, it has 4 letters in it, maybe you see that the second letter is an O, it increases the likelihood that the next word is going to be either work or word, for example. But it also makes it less likely that it won't be any number of other words. And that's the inhibition part. So inhibitory connections provide a negative evidence about the identity of a letter or word. It's what it can't be. Another example of that negative evidence, once you see that diagonal line in the K, this one here, and this one, that provides evidence for a K, and any other letters that have that diagonal line, like maybe an X. But it also provides negative evidence for a letter that maybe has no diagonals. And so we would limit our choices based on that. So that's the idea of the inhibitory connection.